Hello, everyone, and I hope everyone is having a good day. And today we're going to be talking about a really useful, really cool laboratory technique. And this laboratory technique is called titration. And it's a lab technique to determine the unknown concentration We could also do pH, solubility more, but it's usually concentration. Determine the unknown concentration of any acid or base. It's important to note that to do this, we always compare to a known substance. And the way we do this is through a neutralization reaction. So, two important kind of points in our titration. There's something called the end point. Whenever we're mixing an acid and a base together, we always use a pH indicator. So we use in titrations, we use pH indicators. So the end point is the point where the indicator changes color. And the other important portion that we want is called the equivalence point. And the equivalence point is when the moles of H plus in the solution equal the moles of OH minus. And the cool thing is that we just learned that formula. So the neutralization formula is also called the titration formula. We use MAVA equals MBVB, right? So how we set up a titration is that to set up, we have a known substance with a known volume, right? So we want an M and a V, and then we determine the volume of unknown that is required to reach the endpoint. I'm sorry, the equivalent, well, the endpoint or the equivalence point, yeah. So what we're doing is we're adding this unknown into our known, and we're looking for that color change. Now we have some special equipment, and the first piece of equipment we have is something called a burette. So these are kind of two halves of the whole burettes, right? This is the bottom half. This is the top half. This piece would go on top of that piece. RETTE. This here has a funny name called the stopcock, right? And that spins, and this is where it comes out. So it goes drop, 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 right? Now, the reason I want to put on the burette, show you the burette, is to look at where the 0 is. Up here, here's the 1, here's the 2, right? So when we fill up a burette, we're actually not filling it up to a high number, but we're filling it up to a low number. So when you fill this up completely, it's actually going to start at the milliliter mark, kind of like that, right? So how do we read a burette? Well, this is the start mark, right? And that is about, I don't know, 21 milliliters, right? So let's say we start at, let's say, I don't know, 21.5 milliliters start. What happens is you open up the burette, the liquid starts decreasing to a lower level, right? Let's say it decreases down here. Now you might notice that I keep on drawing a curve, right? Curve, curve. The reason we draw a curve is because when water's in a container, it curves like that. The surface literally curves, right? That's called the meniscus. So we always read from the bottom of the meniscus. So I'm going to say that this ends at, that looks like, oh, it went up from 21. That's, hold on, that's supposed to be, no, that's going down. That's 21. Oh, shoot, I heard the first one wrong. Let's try again. So it would start at 20 point, that's 9. That's 20.9, and that's 21.0, so that's 20.95 milliliters. And then it's going to end at, there's 0.1, 0.2, 0.3, 0.4, 20.5. So let's say 21.4, I don't know, 8 milliliters. So how much of this substance from the burette did we use? Well, we didn't use 21.48, nor did we use 20.95. We really used the difference. We have to find the difference. All right. So you do some simple subtraction, and I will get out my calculator to do simple subtraction. I'm sure many of you can do it in your head, but if that was our start and our finish, 21.48 minus 20.95 is 0.53. So we used 0.53 milliliters. And so that's how we would use this contraption, this burette, right? You measure the before and the after. Okay. So as we're doing it, as we're doing this titration, we remember that at neutral, pH equals pOH, which equals 7. And that's because the moles of H plus are equal to the moles of OH minus. So for this particular type of titration, we use phenolphthalein as our indicator. Now, hopefully you're looking at the list and you're saying, Mr. Schreiber, phenolphthalein, that changes at 8. Why would we use something that changes at 8 and not something that changes at closer to 7, right? And I will show you why in something called a titration curve. See my images somewhere. So this is called a titration curve. And what this is plotting is as we add NaOH, what's happening to the volume. So we started with all HCl, we're adding NaOH, and the pH is increasing, obviously. And there's the equivalence point at a pH of 7. And what I want you to note is if that's a pH of 1, let's say this is like the midpoint. Oop, let's try that again. Here's the middle between 1 and 7, approximately. That's not a good middle. That's a better middle. Just guessing. So here's like a quarter of the way up. There's another quarter of the way up. Not perfect. But what I want to show you is that there is from a pH of, I don't know what that would be, 2, right around here, all the way up to like a pH of like 9. There's so little volume change, barely any volume change. It basically shoots up straight from a pH of, what is that? About 2 to a pH of 9. It takes what, a couple milliliters? So because of that, because it takes so little to change in that amount, what we can say is that the added volume is not really that significant in there. The idea is that when you go from, I don't know, 49 to 50, 49.5 to 51.5, right? That 1 milliliter, it's going to change the pH so much that we're going to instantly see that color change. So that's why we use phenolphthalein. Okay. So what we're looking for is we're looking for the amount of acid or base added to reach that endpoint, that equivalence point, to make that color change. And that color change will tell us when that equivalence point is. And then we can work backwards and we can use our formula from yesterday. Titrations are a super useful technique that are used throughout all of chemistry, a lot of chemistry. And you can do more than just acids and bases. You can actually do this with figuring out how soluble a substance is. You can figure out the pH of specific types of acids. You can figure out the concentration of more than just acids and bases of specific salt waters by looking at conductivity. And it's a really useful technique. Okay. So I want to say thank you all for watching, and I hope everyone has a wonderful rest of the day. Bye.